Well, good morning, everybody. First of all, just a quick apology about yesterday's audio quality. I didn't realize it as I was recording, but the base of my microphone was loose, and so anytime I touched the desk I record on, it was making noise, and I realized later that it was pretty annoying. I didn't catch it when I was doing the editing. I kind of tried to do that really quickly to get the content out to you early, but we got it fixed. Hopefully today you won't hear any of that. And just again, I want to apologize. So here's the rundown for today. You're looking at a map, looking at hail since June 27th. But what I'm going to cover today is I'll talk about wildfires. I'm going to talk about the moisture from Beryl. I want to get into a bit of a more kind of in-depth discussion about La Niña at the end of this. And in the middle, we're going to talk about these temperatures that are hitting the West Coast now, but are going to spread across the rest of the country as we work into this weekend. So a lot of hopefully very interesting stuff going on. Now, the map that you're watching, or been looking at here, just looks back, again, from the 27th through the 7th at maximum estimated hail size. I made this for a good friend of mine, Arlen Suderman, yesterday. And what we were having a discussion about primarily was the hail that came through this part of Nebraska. Now, that's not to ignore the events that happened elsewhere around the country, but the questions were about how much damage were done to that region. Because if you look, this hail went right through one of the most productive spots we have in the country in terms of producing corn, just as one single crop to kind of look at here. And so, again, the severe weather that's been had through the midsection of the country, just leading up here to the end of June and beginning of July, possibly causing some pretty significant losses. And based on some of the pictures I've seen from some of you on Twitter that have been sent to me, there's been a considerable amount of damage from those storms last week. Now, in addition to this, let's go ahead and have a look at the total rainfall we've had just for the last 3 days. In this map, again, the main feature on this is going to be Beryl, which did put down in some places 6 to 10 inches of rain, a couple of places a bit more than that. But very heavy rainfall and also some very, very strong winds. And as you just look across the map to kind of gauge the rest of the country with respect to precipitation and knowing where we think the remnants of Beryl are going to continue, I did want to bring up I'm going to do this twice today, but I'm going to bring up a map looking at these precip stats. And yesterday I made the point that where Beryl's moisture went through was already having its wettest year on record. And what we just did was add a whole lot more to that. I'm talking about this part of Texas. This map is really... And there's a lot of information in this map that I think we're going to have to just hone in on here, because since the beginning of the year through the middle of the year, we've got numerous places that are having their wettest years on record. And a lot of you have been questioning me about 1993, especially in the upper Midwest. And certainly through this point in the year, we've had places that have been wetter than 1993, as indicated by the ones that are here. But remember, 1993 carried the extremely wet conditions farther into July than I think we're projecting. And that was largely because of a big southeast ridge here and a larger ridge farther into parts of the Canadian Prairie in the northwest, where we just trapped a boundary right in the middle, and as a result saw nonstop precipitation through that time frame. Now, the other map I'm going to show you like this in a few moments is not going to have the entire year on it, but instead we're going to look back since the beginning of June. I think it'll put more into context the rainfall that's coming through right now. But I did make this map this morning. I looked just at yesterday using the RTMA data to find the maximum hourly averaged wind gust speed, and I looked for the max for the whole day. And I was just curious how strong the winds were in this system. And what we found down here using the RTMA data and then looking at some of the weather stations just to verify was that just off the shore we had gusts that were likely over 100 miles an hour, maybe a bit more. And we carried 60 to 90 mile an hour winds pretty far inland here yesterday. And that's just got me thinking a lot about what the winds could be like as the remnants of Beryl continue to move toward the Ohio Valley and eastern Great Lakes. But because of this, we still have today in Texas 2.3 million people without power. If we just kind of zoom in here, you can see where a lot of those places are. This is poweroutage.us, a great website just to go check out. I believe yesterday at one point we were approaching 3 million people without power, but this just kind of illustrates how powerful even a Cat 1 hurricane can be. So sometimes we focus a bit too much on the category instead of the actual damage indicators that can happen with a tropical system like Beryl. We also had 15 reports of tornadoes. Remember that when you're following the track of a tornado, so for example, Beryl kind of came in something like this, you always want to watch the the upper right quadrant of the hurricane. So if I kind of draw it here, you can divide it up into 4 quadrants, and you always want to watch this quadrant for the ideal wind shear for tropical systems to produce tornadoes. So as it moved into here, that quadrant ran right over this region, and I saw several videos on Twitter yesterday of some of the tornadoes and their subsequent damage that were along this particular region. Now, to show it to you, this was yesterday. I wanted to just get a good glimpse at yesterday's satellite data before we look at where this is this morning. And we've kind of opened up the wind shear in this area, which has kind of spread the cloud field out and stretched it all the way through Missouri and Illinois yesterday. This was last evening. But as I was watching this, we talked a bit about the wildfires in the western United States yesterday. And you can see here, let's zoom in on the west. This is what some of the smoke looked like. So huge fires continued in parts of Utah, but take a look at Northern California. There's a large fire that erupted here, spreading wildfire smoke across parts of Oregon and into Nevada. Same thing with the fires in Washington, and this is the smoke from the wildfires that have extended from the northern Canadian prairie down into parts of the northern tier of the United States. And I was just thinking about this as I was writing my report yesterday, so I went back to one of my favorite websites, the National Interagency Fire Center. And it is important to note that right now, so far through this point in 2024, 2.8 million acres burned. And if you compare that to a year ago, that's like 4 times the amount of acreage compared to a year ago. But the weather patterns were so vastly different a year ago, preventing early season fires. And this 2.8 million number, when you look at the historical averages through July the 8th, is not that far off of the historical average. But just last year, if you just take a look here, I fast forwarded to July 15th of 2023. This is at the point where we were talking about extensive wildfire smoke coming out of parts of Alberta and British Columbia, getting wrapped into, parts of the northern plains and upper Midwest. But those fires, the smoke was originating in Canada, which, if you remember the stats from last year, there was something close to 18.5 million hectares of land that were burned. And most of that was because of large blocking ridges that sat in this area for most of the spring time frame. So I just thought we'd offer up a little bit of context to the to the wildfire smoke that we're experiencing this particular year. I did want to bring up, though, an animation looking at the next 48 hours or so of where we're expecting the vertically integrated smoke numbers to be relatively high. And it just continues to be over the same source regions of the fires I showed you a few moments ago on satellite, with the smoke coming into the northern plains and Midwest, originating in the northern parts of the Canadian prairie, and then multiple fires that are being accompanied with excessive heat that is lined throughout the western United States, which we'll come back to in just a few moments. Okay, where are we this morning? Just as I was recording this is what the radar was showing, kind of a composite radar image across the country as to where the remnants of Beryl are currently moving. And one of the things I was concerned about was how strong the winds were going to be. So I just pulled this up. This is earth.nullschool.net. I show it to you all the time. Just want to let you all know that what you're seeing here is model data. They're not observed, but model data. And this is from the GFS. So as we play this forward, you'll see here that the GFS is actually tightening up that circulation here as we work our way through today into tomorrow morning. As this low curls up, again, the remnants of Beryl curl up in parts of southern Michigan and eventually make it into this part of Ontario. And as a result of that, we expect the winds to be relatively strong. So you've already seen how strong they were coming into Texas, which I think the high-res NAM did a pretty good job at picking up on that. But as we play this forward, this is what the cumulative maximum wind gusts are expected to be. And on my new mapping system, which I can't wait to roll all this out to you soon, you notice there are a few places in here where we're expecting gusts to possibly get over 50 miles an hour. If I kind of zoom in on that area, we can just see where these intense winds are expected to be, which mainly get into parts of Illinois, Indiana, Michigan, and Ohio, with the models picking up on the strongest winds coming out of this part of Illinois into Indiana. So I want you all to be aware that there is still the risk of some wind damage synoptically around this, the remnants of Beryl, this tightly wound low. We're just going to have to keep an eye out on. That's just one of the threats for the next couple of days. Storm Prediction Center continues to keep an eye on this part of the Ohio River Valley today. Again, the primary threat here is going to be tornadoes associated with Beryl circulation. By tomorrow, this moves into parts of Pennsylvania and New York and getting into day 3. Day 3 is a bit of a calmer day across most of the United States with respect to strong to severe storms. So let's go ahead and have a look at the high-res NAM, just kind of picking up on where the precipitation is going to be moving. Kind of the main game in town is the remnants of Beryl. There will be isolated storms on a lot of heat to the east of this. And on the back side, we see the models picking up on the chances for isolated storms here as we work our way into tonight. But as we work into early tomorrow morning, this is 10 a.m. Central Time tomorrow, it appears that most of Beryl will be out of Illinois by late morning, still coming into Indiana, Michigan, parts of southern Wisconsin, spreading into Ontario, and eventually into southern Quebec as well. And you can see that by Wednesday evening, while we're watching this area here for the risk of those strong to severe storms. Models are still picking up on isolated storms on the back side of this as well, so just going to keep an eye out on this for Wednesday night. But as we play into the day on Thursday, we have a bit of a pattern shift overall, which we're going to have more of a conversation about in just a few seconds. Total precipitation, real quick. This is what the high-res NAM picked up on. And if we kind of just zoom in specifically on what's left of Beryl here, I just wanted to add up from Arkansas to Missouri to Illinois, Indiana, and Michigan. I've liked the way the NAM has handled this. It's not a model that we typically rely on for tropical systems, not by far. But given that this is well within the NAM's domain, in other words, it's not going to suffer from boundary condition problems, it seems to be picking up more on where some of the banding could lay down some of its heaviest rainfall. And this does line up well with our other models too. And as you can see, the National Weather Service has issued flood watches right along that narrow corridor that some of the high-res models were picking up on. Now, the excessive heat in the west and in the east and in parts of the southeast continues to be a main story. And we're going to watch the much warmer than average conditions that are in the west begin to broaden out by this weekend as the jet stream just loses some momentum and runs to the north and opens up a larger ridge that's going to anchor itself, I think, around Colorado. That'd be a good spot to kind of pinpoint where the ridge will be by this weekend. But if we just take a look at total precip, we're going to just run through our 5 models real quickly here. This is the AIFS forecast. Now remember, these were the 0Z runs. We don't get the 12Z runs for a while. So they are capturing the rain from last night. That's what's going on here. But you can see there's a pretty good stripe in here of 2 to 3 plus inches of rainfall. Is that echoed in the NBM? It is. We can also see that same region. The 12Z WPC is already in, so you can see it's pulled back on the rainfall in Arkansas, given that it's a newer model simulation. And we've got that, plus the great rains that are desperately needed in this region, which we'll talk more about in just a few seconds, also in the northeast. But again, this contour line is 1.5 inches, just to give some perspective. So there's good chance along a narrow corridor here of 2 to 3 inches of rain, maybe even more than that. This is the latest from the ECMWF, the 0Z run. And I apologize, this morning I had to rerun the GFS. It failed for some reason. I know Nomads is doing some maintenance and some updates, and I don't know if that's what caused. I haven't had a chance to look at my cron logs here. But I reran it this morning just to give you the GFS comparison. But I was waiting on it to finish a couple of the things. That's why I'm a bit later this morning. But I got impatient with waiting, so I wanted to come down and record. So I won't be able to show you the comparison of the GFS to the European early this morning. But to put some context to this, all right, I wanted to bring up, here's my second precip stats map. Now this one goes from June 1 essentially through July the 8th. And where we're bringing in this rainfall right in through this area is critical. And where the rainfall that's coming here soon is also going to be critical to the success of agriculture in those areas. On top of that, it's a very good signal in the models that we're not adding a lot of additional precipitation into this region, also into parts of the Canadian Prairie. While there are still storms, while there's still moisture in through here, it is not the absolute soaker that we'd seen in these two regions as of late. But the large ridge that's in the west is going to continue to feed on the already very dry air in that area, which is why the wildfire threat continues to be a major issue here. And just to point out, we have some spots in California that are having, their driest June through early July on record as the ridges continue to open in that area. Our southwest monsoon at times has been early and active. As you can see here, that's been largely promoted by a larger ridge that slid into this area, back in the end of June and the beginning of July. But I think it's just important to keep these precip stats in the context of the upcoming forecast. Now, that upcoming forecast is going to give us a bit of a shift in the pattern. And I want to show it to you what it looks like here by going to the European ensemble at first. Once we get into this weekend, we really lose jet stream flow. It's going to stay way up here to the north. We've got a few large epicenters of ridges, two of which are right here. And what this is going to do is this is going to weaken the flow across the United States, back off on the precipitation chances, and bring in quite a bit of heat. And as we play it forward, we see that the model, the ensembles, still keep this feature. We've had this for much of spring. But they kind of open up this ridge and get the flow coming over the top, something like that, as we work our way out to about the 17th, 18th, and 19th. Now, where I really like to compare each day the ensembles to other forecast models like the artificial intelligence is that when you average, I think this is a 51-member ensemble average here, when you average it all together, sometimes some of the subtle features get washed out. So, for example, if you look all the way out there, Sunday the 21st of July, the ensemble's put its biggest ridge over the Four Corner States. Flow comes in over the top like this. We have an extensive Bermuda high, which we expect to keep moisture rolling around the southern and western sides of that. But if you take a look at the AIFS, the artificial intelligence, you see it's got a bit more amplitude to it because this is not running in ensemble mode. And what I'll be curious about is, do we actually come back to where we've been? So maybe on the 21st, that's a Sunday, we need to see how consistent the artificial intelligence model is with tossing this deeper trough in. Because what this could do is, as it sweeps through, it returns a front. And we know there's going to be plenty of open Gulf moisture, and this could indicate, a late July, third week of July, getting into the fourth week of July, system that rolls through the midsection of the country and drops storms again. So we'll be watching out for that. But just remember that there are significant differences between the ensemble, the operational runs of those models, and the AIFS. But let's go ahead and have a look at this morning's 0Z European model. We've already seen where the remnants of Beryl are expected to move. We looked at the wind field as well. We see that moving through parts of Ontario, Quebec, and the Northeast. On Thursday, on the backside, maybe some rain coming into parts of Illinois, desperately needed moisture coming into the Carolinas, and working our way into Friday and Saturday. What we're getting here is just flow around the Bermuda High. Very weak lows moving through the Canadian prairie by Saturday, and much of the country on Saturday is going to be hot. There will be possibly some isolated storms that pop right in through this area. The model's been pretty consistent with that, but temperatures getting deep into the 90s through this whole region, which means we're going to see some isolated storm events, but they could be producing locally very heavy rain that the model can't pick up on. Again, the moisture, though, that's coming into this area, all just coming around this large Bermuda high that's influencing the flow. And I love to see it. We need every ounce of moisture we can get into the Carolinas, Virginia, and up the East Coast. Into Sunday and Monday, weak disturbance moves right over the Great Lakes as forecast by the European model. And as we play out there to Tuesday and Wednesday, what I'll be watching, remember, this is out there on the 17th, 18th, 19th. Can we get a little trough to sneak again through the Great Lakes, bringing in a chance for our frontal boundary? Do we maintain the isolated storm behavior along the Gulf Coast? That seems to be the case. We'll be watching out for how this pattern evolves toward the middle of the month, which suggests, once we get out there, better storm activity toward the end of the month of July. All right? As it stands, though, over the next 10 days, this is the best probability of getting an inch of rain. So it's dominated primarily at the flow around the Bermuda High and Beryl. But remember, those systems that roll through the Great Lakes, okay, we could get some better storm action out of those as we work through these next 10 days or so. And you can see the influence of the southwestern monsoon continuing to go here. But for most of the next 10 days, we got a lot of folks that are quite dry and are going to be getting very hot in this pattern. Now, week 2 is where things really start to shift around a little bit. And I am not settled yet on where the ridge placement is going to anchor. Some of the models say right over the Four Corner States. But we've seen when looking at the artificial intelligence, we may be able to break that down getting out there into week 2. So I'm going to show you the 3 forecasts, and we're going to take them at face value today, because I think once we get into that June 16th to June 22nd time frame, we might be able to see a little bit of a shift in the North Pacific jet stream behavior that could kick systems across the country. That's what I'll be on the lookout for. Now, let's turn our attention now to temperatures, and I want to show you a ranks map from June 24th to July the 8th. We're looking at temperature ranks. So much of the Midwest, upper Midwest, plains, getting into the Canadian Prairie have been cold, while we've just lined the southern tier of the United States with a lot of heat, and much of California down into the desert Southwest is having its hottest on record stretch of days when you compare the 24th of June to the 8th of July, going back to 1893. So this would be that hottest such time period. So you've seen records being approached and set and broken in this area, and the excessive heat just continues into that region for a while. I did want to show you what was going on in the pattern, though. Things have gotten a little bit more meridional. If you just kind of look at how bumpy things have been here. Dominated a lot by this broad ridge. That's where the Bermuda High's been. Deep trough of low pressure that's just sat in north central Canada, the archipelago, getting to the Hudson Bay, and eventually down here into the northern plains of the United States. But there's our highly amplified ridge that we've seen since the end of June that's sat across the western United States. And this pattern is what's driven what you just saw. Now remember, by the time we get into this weekend, we still have something like that. Another trough here. There's our trough that's in Canada, but a very, very northward retreat of the jet stream. And as this ridge opens, could we get storms cascading over the top coming to the Great Lakes? Yes. Coming into the Midwest? Possibly. Are storms going to come around the Bermuda High into this region? I think so. But heat is going to open up as this ridge really takes hold around these Four Corner states, again, this weekend. So watch what the temperatures do in response. Heat, just a scorcher on the west coast again today, very hot in the northeast. This is all cloud cover driven from Beryl. As we get into Wednesday, same scenario pretty much in terms of the temperature distribution and why. But once we get into Thursday, Friday, and Saturday, you start to see a lot hotter than average conditions rolling across much of the country. Several triple-digit highs are expected in the plains. We're going to be well into deep into the 80s, into the 90s throughout the Corn Belt. Very hot in the southeast. And playing out there to Sunday and Monday, that just continues into early next week. Some of the longer-range forecast models, again, just kind of keep the heat around, although there's some indications that we could get some cooler weather in and around the Hudson Bay and surrounding large geographical area due to the flow coming around what could be broader troughing happening in this area. But again, that's about 10 days from now. Day 10 through 15 really reflects, though, the northward repositioning of the jet stream. And I think there's going to be a lot of heat across much of the lower 48 and the Canadian Prairie. And speaking of the Canadian Prairie, let's just look at it from the European model. Seeing this warmth get into that region, this is going to be makeup time, because for much of spring into summer, there's been very limited chances of getting moisture into this region. Now, why is Texas? Why is the southeast staying cool? Well, Bermuda High is kind of influencing this flow, and maybe this is helped along by cloud cover. Now, don't get me wrong, it's still going to be hot down in southern Texas. It's going to be hot in the southeast. It's summer. But with the chance of moisture coming in, I think better odds of getting bigger storms. So that walks us through the next couple of weeks looking at all the models here. And what I want to spend a little bit of time on at the end of this is talking a bit more about the longer range forecast and then getting into a discussion about La Niña. So when you look out there from mid-July to mid-August, this is just the newest update. I think so much of the story is going to be written on the strength of the Bermuda High with not only tropical cyclone guidance, but also on the moisture that's going to keep the Gulf of Mexico open. We see higher than normal pressure here where the waters have begun to warm up. And that will, I think, keep the jet stream relatively far to the north. But it's becoming very difficult to find where there could be ridge placement in the United States, surface high pressure specifically. The models are keeping the driest conditions. You saw this yesterday in a big area in the Central Plains, the Western Corn Belt, Canadian Prairie. But we have to call this into question because the models have predicted these areas to be dry in the past, and we've seen storms roll through there. And certainly we've got plenty of moisture in the soil here, and nothing's blocking the Gulf of Mexico. So I continue to see this as more of a hot and stormy summer pattern, meaning that this temperature outlook makes a bit more sense to me than that precipitation outlook that you just saw. So we'll leave it at that as we think out there to July into August until we've got some better information on how things are going to transition week by week. From here, I wanted to show you something about the tropics. I mentioned yesterday all of the Saharan dust, and you can see it pretty clearly yesterday on satellite. All of this kind of discoloration, not this, this is bands of sun glint from the satellite, but all of this is just dust. We can see from the forecast here that over the next 10 days, quite a bit of Saharan dust is moving across the open Atlantic. And it's one of the factors that could limit tropical cyclone development in the near future. The other big factor, I think, has to do with just the flow of the atmosphere in the upper levels. So remember, when we look at these Hofmuller diagrams, this being today going all the way through the 23rd and 24th, these colors here represent rising motion over these geographies, and these represent sinking. We've got some sinking motion now and more sinking motion later coming to this region. Maybe you can see it better if I just kind of show you a sequence of maps. So when you look at this, I'm going to leave them kind of small here. Rising motion better here, sinking motion in this area. Can you kind of see that? But we'll keep an eye on Africa gaining better chances of producing more African easterly waves. That's off of the convection in Africa, again, later this month. But I just think the next 10 plus days, we see less activity in the tropical Atlantic because of these two main factors: suppression and more of the dust. All right, so one thing to consider about this tropical season, when we consider the effects of this ENSO-neutral situation we have in the equatorial Pacific, the big influence it has on the tropical Atlantic is on reducing vertical wind shear. So anytime a tropical system forms in the Atlantic, wind shear can immediately disrupt the vortex, spread the heating, and kill it. So we watch, compared to historical averages, which is the black line, how the wind shear this year, which is in blue, how it looks, right? And we've been pretty low. It's been below average. And if it maintains down here, that means any system that should develop later in the year, this being the main part of the hurricane season when the wind shear is the lowest, if we're lower than average, we'll have a much more conducive environment to making these tropical systems as we approach August, September, and October, the main 3 months. All right, let's talk about La Niña. Yesterday, I was kind of reading through the comments. I have not had a chance to do that while I was on vacation. Again, terrible internet connection. But there was an interesting thread started by a viewer, I believe, I should have looked this up again, Nuggy Fresh and a set of numbers. That was who made a sequence of comments. And the comments were just about my analysis of El Nino. So I thought we'd just chat a bit about it. It was a great discussion that was being had there. So I've made the case that I don't think La Niña is a factor right now. And I said we're in ENSO-neutral conditions. If we look at these ocean temperatures, there are a few places of some cool anomalies here, but I'm waiting for the atmospheric response. So I've kind of made a case that I think most of the pattern across North America has been driven, in fact, for Europe as well, by these two large warm areas in the North Pacific controlling the jet stream. And then, of course, the very warm ocean temperatures in the Atlantic, and the fact that in the last month I've seen the PMM come back toward neutral, and even the PDO responding here by going toward this warming trend. But I made a comment that I do not see La Niña being a major influence until we get much, much later into the year. And what I think Nuggy Fresh was saying was like, why aren't you looking at the ocean temperatures from the buoy network and trying to assess what's below the surface? And maybe or I'm not sure if it's a he, but that person's a newer viewer of my content, but we do look at that quite a bit. But I just want to make a case, and I hope it sparks some good discussion. So we know that the new European model is now much less aggressive as we go into September, October, November, and December at producing a big La Niña event. That's December. We would expect, if there's a La Niña, for it to be approaching some sort of a peak here, but the new European forecast didn't do that, and we looked at that in depth yesterday. What I do like about the Bureau of Meteorology is that they will show you several models compared to one another. We've done this many times. Their forecast, by the way, is also INSO neutral all the way through December, just to make a point. But what they do is they compare their forecast to the Canadians, the Europeans, the Japanese, the French, the US, and the British. And through July into August, September, October, and let's get out there to November, you notice that the European model is third behind Meteo France and the Bureau of Meteorology at keeping things very INSO neutral. NOAA is the most aggressive at developing La Nina conditions by the time we get into the fall time frame. And for me, I think that would be the time frame over which I would expect La Nina to have its greatest influence on the pattern. But I think what Nuggy Fresh was talking about was we have a buoy network. It's a massive buoy network across the open Pacific Ocean. And I often just show you the top-down view from satellite, which is the ocean temperature analysis. And I think the comment was about how much cool water was here and that it has surfaced at times in the East Pacific. So if you want to get yourself oriented, this is going down in the ocean. This would be over by South America, and this would be over by Indonesia and Australia. So this is the equatorial Pacific going down. Now, what we often look for are wave-like motion in the ocean temperatures at depth to see if and when this is going to upwell. But there are some standard regions over which we try to assess where there is El Nino and La Nina. And one of those is right here in the middle. That's Niña region 3.4. There's Niña region 3. There's Niña region 1+2, which is over here. And right now, if we were to make a case that there's some sort of La Nina signal, it'd have to be a very, very east-based case on this. But what I always want to do is I want to assess the atmospheric response. So I just want to explain my position on this. And I'm looking for strong responses in trade winds that would have to then take momentum from the westerlies, both in the northern and southern hemisphere. And our Southern Oscillation Index has been hovering around 0. In fact, for a while, it's been negative. We would need to see this go way positive in order to have a discussion about there being strong La Nina-like influences. I also pull this up. This is near surface winds from June 1 up until July the 6th. And if we were going to be looking for a strong signal from an early influence of La Nina, I would want to be seeing stronger than normal winds out of the east here. And I just don't quite see that yet. In fact, we see just north of this winds that have been anomalously strong out of the west. So that to me is just not a good signal to say that La Nina is a major factor. For some kind of information on this, I pulled up an Ocean Nino Index from 1990. This is where our current El Nino ended last winter and is starting to fade. So if we just take a look, excuse me, at a recent year where there was a stronger transition to La Nina, I'm going to pick out 2010 just to show you what I'm going to be looking for. And in 2010, same time period, June 1 to July the 6th, we had already begun to see stronger trades here. See how they're coming in that direction. And take a look at the South Pacific. We were getting stronger trades coming around like this, indicating that by the time we got later in the season, like October to December, we were going to be getting very strong trade winds in this area. And that is telltale sign of strong influence of a La Nina. And what that does is it steals the momentum from the North Pacific and even the North Atlantic. Can you see how we were blocking this up with a big high pressure cell here and another one there? That's what I'm going to be looking for. So as I'm staring at where the influence of La Nina is going to come from, I just don't see it to be a factor until much, much later in the season. That's the argument I'm trying to make. I just wanted to provide some clarification on that. So along those same lines, I also wanted to bring this up. This, let's blow this up for us here. This is just to make a point about summer for me. This is what I often look at. So you might say, why do you not talk more about La Nina and El Nino and influencing the summer pattern? It's because when you try to correlate a variable like temperature or precipitation in June through August to historical El Nino and La Nina events, I find that the correlations are just too weak to rely on. If you notice, most of the colors on this graph live between minus 0.3, 0.4 and plus 0.3, 0.4. That's on the temperature side of it. And on the precipitation side of it, it looks something like this. And I look at all of that and I just say there must be other factors dominating the pattern, and that if we're going to see when El Nino and La Nina have their biggest influence, I just think it's during the cold season for the Northern Hemisphere. So one of the models that is most aggressive, let's shrink that up, that is most aggressive on developing La Nina are the model suites we run in North America, part of NOAA. And here they are. That's the October, November, December signal. That's pretty aggressive, much more than the European model. And that's likely the reason why the August, September, October precipitation pattern features a very active hurricane season, but dryness in the interior of the country. And into September, October, November, fall, much drier throughout much of the United States. And then even out here to October, November, December, quite dry as well. You say, well, why does it look like that? Well, I think the influence of La Nina in the forecast produced by the NMME, which we just talked about yesterday, is reflecting this. You see, the correlation factors in October, November, December, and I changed my color bar. I'm going to be very clear here. This is now from negative 0.5 to 0.5. I did the other ones from 1 to 1. But what we tend to see is if there's an El Nino, we tend to be wetter where the colors are more red. But we have a La Nina. So we're expecting wetter conditions earlier in the Northwest and drier conditions in through this region if La Nina is the main factor in this fall. So I just wanted to bring that up. I thought it was a great discussion to watch yesterday, but just wanted to provide some clarity there. So I'm going to stop here and we'll get prepared for tomorrow's briefing starting later on this afternoon, this evening, and we'll talk to you in the morning. Appreciate it. Thanks.